All right. Welcome back. Remember to like, subscribe, and share if you know anyone who's trying to take the AWS Security Specialty exam. So we're going to continue with our final section, Domain 6. This is going to be management and security governance. I have a couple questions here. We're going to go over some of the correct, incorrect questions and see why with some supporting documentation. So let's begin. All right. First question. Security engineers deployed an AWS config rule that detects changes to a security group and sends notifications when the rule is non-compliant. However, recent changes to the security group, which were compliant with the AWS config rule, went unnoticed until connectivity issues were noticed by the users. Now the company needs a solution that can initiate an alert to a specified email address when any changes are made to the security groups. What do you recommend? So the answer is A. Enable CloudTrail and configure the trail to send logs to Amazon CloudWatch logs. Configure a CloudWatch metric filter for the log group with a filter pattern on all security group changes. Create a CloudWatch alarm based on the log group metric filter to publish notifications to an SNS topic. So why is this correct? So CloudTrail captures all API calls, including security group changes. CloudWatch metric filters can detect these changes in real time and trigger SNS notifications for any change, not just compliance violations. This provides the near real-time monitoring required. So why are the other questions incorrect? So let's see. Delete the database config rule and recreate a new rule. Okay. So config only triggers non-compliant changes, not all changes as required. So that's why that would be. So let's see. Athena tables. All right. Non-partition Athena tables. So why is this incorrect? So Athena cannot trigger notifications. And Athena is for querying, right? It's not for real-time alerting. So you can knock that off. And then CloudTrail Lake. So a CloudTrail Lake can't trigger notifications. This is designed for SQL analysis, not real-time monitoring. So let's see if we can get some documentation to support. Okay. How to monitor changes. All right, so there's two methods. Method one uses config to monitor changes to the security group's configuration. Method one views a change to the security group as a compliance risk. Using this method when you want to bolster your company's compliance management, right? Method two uses CloudTrail and CloudWatch events to identify API calls that could change the configuration of security groups. So method two does this. They're both pretty related, right? And you can see here where that's all configured. All right, so the Lambda function here with elements to represent the ports, protocols, and everything for the permissions. You can go in here with a Lambda execution role and a config role, and then create a security group for this. And then here's a more specific one, right? This is the object being changed, so a security group, right? So you focus on the actions, the API calls, and you can invoke a Lambda function when the API calls shows authorize security group ingress and revoke security group ingress, or you could do other event changes. All right, so let's hope you understand. All right, next question. The company uses Amazon EC2 instances fronted by an application load balancer with Amazon RDS MySQL as the database. Now the company wants to store sensitive client data and needs to follow strict security and compliance guidelines. Data must be end-to-end secured while in transit as well as at rest. The company needs a solution that can implement strict security guidelines while keeping the cost and operational overhead to a minimum. What combination of steps meet the requirements? This is showing A, B, and C. Use TLS certificates from Certificate Manager with an application load balancer and deploy self-signed certificates on the EC2s. Ensure the database client software uses a TLS connection to Amazon RDS and enable encryption of the RDS database instance. And then encrypt on the Elastic Block Store, the EBS volumes, that support the EC2 instances. So why is this correct? Okay, so this combination provides end-to-end encryption. That includes certificate manager certificates on the load balancer, which is cost effective. Then it has self-signed certificates on the EC2 instances for backend encryption. And then you have TLS to RDS, the relational database, for database encryption, and block store encryption for data at rest. So why are the other answers incorrect? So Cloud HSM. So this is unnecessarily expensive and operationally complex for this use case. You could do it, but this adds a lot of operational overhead. All right, so third-party certificates. Okay, so then again, it is expensive. This adds operational overhead compared to Amazon Certificate Manager. And finally, 3. All right, so CloudFront and WAF. So this is HTTP to EC2 instances, right? This violates end-to-end encryption requirements. All right, so let's get some certificate information. Let's see if we can find this. All right, so this will be a lot. Let's find encryption. All right, so let's see. If you use TLS inspection on a firewall, you must configure an ACM certificate for the decryption and re-encryption of SSL TLS traffic going through your firewall. That's not exactly what we're looking for, but it's closer. Let's see. Let's see. Application load balancer. Okay, so let's see. So in general, serve secure content over SSL TLS load balancers require that SSL TLS certificates be installed in either the load balancer or the backend EC2. So ACM is integrated with Elastic Load Balancing to deploy certificates on the load balancer. That's how you cover that. Okay, let's see. Okay, so SSL TLS connections provide us a layer of security by encrypting data that moves between your client and database instance or cluster. That's where you're going, right there. All right. And here you go, some information for connecting the database to the database's engines processes for implementing that secure connection. Each database has its own process for implementing SSL TLS. You can learn this with the links at this following page. All right, so that's how you're going to get that. You can see the root certificate and intermediate certificates. All right, this is how you make sure everything is encrypted. And then, okay, let's see, encrypted. Woo! Yeah, this is going to cover all of this. Okay. So you encrypt EBS volumes by enabling encryption using encryption by default or enabling it when you create a volume you want to encrypt. When you create the volume, you can specify the symmetric encryption key to use to encrypt the volume. If you do not, the KMS key that is used for encryption depends on the encryption state of the source snapshot and its owner. All right, so you can see a lot of information here on encryption. All right, this is very important for your storage. We've covered this before, but it's good to have this in your repertoire. All right, next question. A company maintains a robust security posture by use of AWS services like Config, Firewall Manager, GuardDuty, Inspector, Detective, and Trusted Advisor. Earlier, the company was using a custom dashboard to aggregate information about its security footprint. The company has now decided to use Security Hub to help assess its AWS environment vis-a-vis the security best practices. Which of the following statements are correct about Security Hub integration with other AWS services? So this is A and B. So you have Firewall Manager sends the findings to Security Hub when Shield Advanced is not protecting the resources. And then Security Hub sends the GuardDuty findings to Detective to visualize the investigation's findings. All right, so why is this correct? So Firewall Manager automatically sends findings to Security Hub when resources lack Shield Advanced protection. And then Security Hub integrates with Detective, and it allows pivoting from GuardDuty findings to Detective for investigation. So why are the other ones incorrect? All right, let's start with this one. So this is about Detective and Security Hub, right? So this is an incorrect direction, right? Detective receives findings from Security Hub, not the other way around. It's a misdirect. All right, so Security Hub retroactive. All right, so Security Hub is global. This is what this is saying, okay? So what you need to know is that Security Hub is a regional service, not a global one. All right, you can configure it in different regions. And let's go into Trusted Advisor. So this is incorrect because it's an incorrect direction too. All right, Security Hub sends findings to Trusted Advisor. So Trusted Advisor can make give you trusted advice. So let's get some integration information. All right, let's see. Firewall. All right, so here you go with the directions, right? So firewall can send findings. Okay. And we see GuardDuty, we see config, we see inspector, and then boom, we see detective receives it. And then we see trusted advisor receives it. All right. So that covers that portion of it. Yeah. And so you can see a lot of this information here that will cover specifically how this is done, right? See, firewall manager sends findings when Shield Advanced is not protecting resources. Boom. That's where you go for that one. And then let's see if we can find detective. Okay, so detective collects information from your AWS resources. Security Hub's integration with detective allows you to pivot from GuardDuty findings in Security Hub's CSPM. And then you can use detective tools and visualizations to investigate them. There we go. All right. And we probably have this, which will give you a little bit more information on Security Hub broadly. Okay, so this is the general use case for Security Hub. And then on the left, you can see the menu that goes deeper into the product. All right, we're going to close out that and go for the next question. All right. The development team at a company deploys to their AWS production environment through a continuous integration, continuous deployment pipeline, CI/CD. The pipeline itself has broad access to create AWS resources needed to run the application. The company's security team wants to allow the development team to deploy their own IAM principles and policies for their application. However, the security team also needs a control mechanism that requires all resources created by the pipeline to have minimum privileges that comply with the security guidelines. What two options will you combine to address this? So this is saying A and B. Oops. All right. One, create an IAM role for the CI/CD pipeline to be used for deploying application resources. Then the security team should create a permissions boundary policy and attach it to the IAM role used by the CI/CD pipeline. So why is this correct? So the CI/CD pipeline needs an IAM role for deployment. Permissions boundaries allow the security team to set maximum permissions while delegating the IAM principle the ability to create the development teams, which ensures compliance with security guidelines. All right, so why are the other ones not correct? Okay, so let's see the service control policy approach. All right, so this requires AWS organizations, which is not mentioned in the use case. So it could be good if it was mentioned in the question, but it wasn't. All right, so think about the scope of the question and you have the scope of the answer. So let's see the development team creating boundaries. So basically, the security team should control permissions boundaries for centralized governance, not the development team. So this is a soft, incorrect answer, but if you read this question closely, you should get it. And finally, the resource-based policies. Okay. Okay, so why is this incorrect? So this is unnecessarily complex. Not all AWS resources support resource-based policies. So you need to know this to know which ones are incorrect. That's how you deduce how to get there. All right, so let me see. Okay, so you'll have some information here. Identity policies in your AWS account that are used to enable access in scenarios such as human access, machine learning, and deploying pipelines. Let's go down here a little bit more. All right, so you want to integrate a pipeline with the CI/CD pipeline. Okay, requires IAM roles, have a permissions boundary attached. Boom, that answers that. And then let's see, the same permissions boundary policy can be centrally managed and attached to IAM roles created by other pipelines at the corporation, which works for this. And you can see a sample of the policy here. Okay, and then in this section, you'll see the identity-based policy that can be attached for this. So you can have a role for the CI/CD pipeline to deploy application resources, which was the question. A read-only role for the central cloud team for temporary elevated access, and a read-only role for members of the application team. All right. Hope that answered your question satisfactorily. Let's go to the next one. A data analytics company wants to move all of its clients' belongings to the regulated and security-sensitive industries, such as financial services and healthcare, to the AWS cloud, as it wants to leverage the out-of-box security-specific capabilities offered by AWS. The security team at the company is developing a framework to validate the adoption of AWS best practices and industry-recognized compliance standards. The management console is the preferred method for the in-house teams wanting to provision resources. Which of the following strategies would you adopt to address these business requirements for continuously assessing, auditing, and monitoring the configuration of resources? This is going to say A and B. Okay, so Leverage config rules to audit changes to AWS resources and monitor the compliance of the configuration by running the evaluations for the rule at a frequency that you choose. Develop config custom rules to establish a test-driven development approach by triggering the evaluation when any resource that matches the rule's scope changes in configuration. Then, enable trails and set up CloudTrail events to review and monitor management activities of all AWS accounts by logging these activities into CloudWatch logs using a KMS key. Ensure that CloudTrail is enabled for all accounts as well as all available AWS services. Okay, so why is this correct? So config provides continuous compliance monitoring and evaluation of all resource configurations, okay? CloudTrail provides an audit trail for management console activities, which is the preferred method mentioned in the question. So why are the other ones incorrect? So let's see, CloudWatch agents, okay? This focuses on SDK logs rather than the management console activities as specified. Remember the console versus SDK, all right? EventBridge, all right? With automation. So this use case focuses on assessment and monitoring, not automatic remediation, okay? All right, and then CloudTrail. Okay, so this focuses on API activities rather than the management console usage, okay? All right, let's see if we can get some documentation up here. So here's where we have all of this. So management events provide a lot of information on this, right? So this is about security, on the policies, registering devices, configuring rules for routing data. All right, so this also includes non-API events that occur in your account. Boom. So that includes when a user signs in your account, CloudTrail logs. So this is good for that CloudTrail portion of the question, okay? CloudTrail will monitor all of that activity, right? And it'll do the data events as well, right? So that's the data level, object level, all of this information can get logged, tracked, and you can use this to make sure that all your accounts are monitored. All right, and then let's go into config. So this is a broad example of it. Okay, so you can use this when you create, manage collectively, right? You can use this to keep track of your resources and help oversee your application's resources. So how do you do this? All right, auditing and compliance, which we were just talking about. So if you have data that requires frequent audits, you can use this. You can use config to do this. You can use this to manage and troubleshoot, right? When you use multiple AWS resources, a change can be documented. And then with config, you can see how that was done. Okay. And then let's see if we can find custom. Okay, so there you go. So you get remediation of non-compliant resources that are created by config rules. And you can find that here under remediation. All right, which we've covered earlier. Let's go back. Let's save this. Okay, so I hope that answers your question satisfactorily. Let's go to the next question. All right, a company wants to allow its developers to create temporary environments to test their code using the latest Linux distribution. To control costs, the company wants the teams to create Amazon EC2s using only small instances while also restricting the size of the attached EBS volumes. To comply with security requirements, the developers are expected to create only encrypted volumes and use a non-standard port for secure shell access to the instances. What's the most optimal way to proactively evaluate resource configurations in CloudFormation templates without writing custom code in Python or other languages? So this is going to be A. So use CloudFormation Guard, CFN-Guard. This is an open source tool that helps you write compliance rules and validate the CloudFormation templates against those rules. Now, why is this correct? So CFN Guard uses a domain-specific language for writing compliance rules without requiring programming languages like Python. It's specifically designed for proactive template validation against company policies. So why are the other ones not correct? Okay, so CFN lint. Okay, linting only validates syntax and structure, not compliance with company policies. Let's see, the CDK. Okay, so the CDK is a good framework for infrastructure as code, not a compliance validation setup. And then drift detection. Okay, this is not necessarily related. So This would compare deployed resources to the templates, not proactive template validation. This would be something you use after the fact. So some of these are generally related, but they're not answering the question specifically. So let's get some documentation. All right. Okay. So, all right. So CDN Guard or CFN Guard, excuse me, open source tool that helps you write compliance rules using a simple policy as code language, helps you validate CloudFormation templates against those rules to help you keep your resources in compliance with your company policy guidelines. Customers, engineers, and professionals, consultants use this as part of their private beta. And based on private feedback, it's public on GitHub. And you can use this to evaluate templates locally as you write them and after you submit them to be deployed in your CI/CD pipelines. This article covers it. You can keep going all the way down to find out more about how you would use this. But stuff like OPA, Rego are going to be a little more popular, especially nowadays. Let's go to the next question. Okay. Financial services company recently faced a security event resulting in an S3 with sensitive data containing PII, personally identifiable information, for customers being made public. The company policy mandates to never have public S3 objects, so the governance and compliance team must be notified immediately as soon as any public objects are identified. What are the following two solutions you would combine to address the requirements of the given use case? This is going to be A and B, event-driven. Okay, so we're going to actually start with B, which is enable object level logging for S3, and then set up an EventBridge event pattern when a put object API call with public read permissions is detected in the AWS CloudTrail logs, and set the target as an SNS topic for downstream notifications. 1. And then 2, configure a Lambda function as one of the SNS topic subscribers, which is then invoked to secure the objects in the S3 bucket. Okay, so why is this correct? Object level logging captures the put object API calls with public read permissions in the CloudTrail. This is perfect for seeing this public object. 2, EventBridge, event-driven situation, can analyze the logs, trigger an SNS notification. Perfect. And from there, a Lambda function can automatically remediate this and secure the objects. So why are the other ones incorrect? Okay, so let's see which one I'm going to go through. So let's see, S3 event notifications. Why is that incorrect? So S3 event notifications cannot check if API calls are made, especially ones with public read permissions. It's just, it's not possible. Okay, so Trusted Advisor. Why is that incorrect? So Trusted Advisor only provides weekly or recurring notifications. This is not a real-time detection, right? Which is implied by notified immediately as soon as any public objects are identified, okay? And then finally, Access Analyzer. So Access Analyzer cannot do something that's near real-time as far as results, right? So it can't invoke that Lambda function, and it's not designed for real-time detection. Okay, so how do we do this? Okay, so let's go here. So CloudTrail, okay. To enable CloudTrail for all your buckets, boom. And then let's see, public, no. Logging for objects, you can use the console to configure CloudTrail Trail to log data events for objects in the bucket. That's your portion right there. It supports logging object level API operations such as get object, delete object, and put object, which we just covered. These are called data events, which we already covered. All right, and then let's see. So this is how you would enable this for it. And let's see if we can go for notification events. Okay. So first out, this is an SQS. So use S3 to receive notifications. So add a notification configuration that identifies the events you want to publish. Object tagging, object ACL put events, that's one. Okay. And supported event types, this might have it. And you can see here what's supported, SNS, Lambda, EventBridge, okay? So it ties more of it together. And then object removed. S3. Using EventBridge. Let's see if that has it. I don't see it. Okay, so it's not, I don't see this on here. Let me see. I have one more resource. SNS. So this is how they can receive the messages. Application alerts. So this is how they would be. Okay, boom. Okay, there you go. A new file uploaded to an S3 bucket. That's a put object. Okay, and with that, you have all these options for notifications. And you have the cost filtering for there. So there you go. All right. Okay. Next question. Okay. An application deployed on an EC2 instance needs to read from and write files to an S3 in the same AWS account, account 1. The application also reads but doesn't write files from an S3 in another AWS account, account 2. 3 teams access the company's data: the central cloud team, the application team, and the data lake team. The central cloud team has 2 security requirements. All AWS API calls across all accounts must be encrypted in transit, and accounts can't leave the organization on their own. Then, least privilege policies or permissions should be configured for the application and account 1 to access files from the S3 and account 2. Which of the following options would you combine to implement the solution? This is saying A and C. All right. Let's start with A. Okay, so this is saying create a service control policy that denies all requests that are not sent using SSL TLS and also prevents an account from leaving the organization. Apply the SCP to the root of the organization. It's good policy. Or it's appropriate. Okay. And then the application team has to create an IAM role in account 1 that the application running on the EC2 will use to get objects from the S3 in account 2. A resource-based policy has to be attached to the bucket in the data lake account in account 2 that grants full access to the role in the application account in account 1. Now, why are these correct? Service control policies enforce organization-wide security invariants like SSL TLS encryption and prevent account departure. Always a good choice. Then, the cross-account S3 access requires both identity-based policies in account 1 and a resource-based policy in account 2 with least privilege access, which would be read-only as specified from this question. So why are the other questions incorrect? So permissions boundary. All right. Permissions boundaries are not designed for organization-wide controls. You can't scale them up, right? And let's see, what are we going to do? Let's say full access. All right. All right. Is that what it's asking for? No, this is yeah, this is asking for full access, isn't it? Yeah, this is asking for full access almost, right? Okay, so the application running on this will get objects from this. Resource-based always has to be attached to the bucket in the data lake that grants this. All right, so this is basically, okay, I think I miswrote this question. So this is supposed to be a full access, right? So this is supposed to be an overextension of privilege, which would violate the least privilege policy. Application team is an application needs to get objects attached to the bucket of the data lake. That basically, I think I copied this question twice. Oops, my apologies. Or this answer twice. All right, then the identity-based policy, okay? All right, so identity-based role, right? So this is wrong because the role should be in account 1, not account 2. Boom, that's a real simple one. All right, let's go to the next question. A company maintains independent AWS accounts for its departments. For a specific requirement, a user in the finance account needs full access to an Amazon bucket in the audit account. The security admin has attached the necessary IAM permissions to the user of the finance account, but the user still has no access to the S3 bucket. What additional configuration is needed for the given requirement? This can be A, create an S3 bucket policy in the audit account that allows access to the S3 bucket for the user from the finance account. So why is this correct? So cross-account S3 requires both identity-based permissions, which is already configured, and a resource-based bucket policy, which we have talked about before and we're currently talking about. So the bucket policy must be in the account that owns the bucket, the audit account, and that be able to grant access to the external user. Boom. So why the other answers incorrect? All right, so let's see this bucket owner. Okay, so bucket owner with the ACLs. So when bucket owner enforced is enabled, ACLs are disabled. This renders this one ineffective for having a secure bucket. So this would make it unlikely to be enabled in your account, right? You should not do this. The bucket policy in the finance account. So this is a misdirect, okay? So the policy must be where the bucket resides, which is the audit account, all right? And then the bucket ARN as the principal. So you can't use S3 bucket ARNs as principals and trust policies, all right? So let's see. All right, so let's get this. So here you go. You have IAM policies and resource-based policies for programmatic access to S3s. That's it. That covers it, right? For ACLs for programmatic. And this answered that bucket owner enforce right there. All right. And then it goes in here. Oops. IAM-based and resource-based bucket policies. All right. You can troubleshoot this, but you manage cross-account access and audit the S3 buckets permissions. You go through here. So you have the S3 in account A, the IAM role user, IAM user role to get it, and then you have role permissions called bucket, put object ACL. All right. And then you configure a bucket policy to get object and put object. Boom. That covers it. Okay. So next question. A data analytics company uses Amazon GuardDuty to identify unexpected, potentially unauthorized, and malicious activity within its AWS environment. The security team at the company wants all medium, high severity findings to automatically generate a ticket in a third-party ticketing system through email integration. What would you suggest is the most optimal solution? Okay, so this is going to be A, right? Create an Amazon EventBridge rule that includes an event pattern that matches the medium, high severity GuardDuty findings. Then set up an SNS topic. Configure a third-party ticketing email system as the subscriber to the SNS topic. Jira, something along those lines, right? And then set the SNS topic as the target for the EventBridge rule. So why is this correct? So GuardDuty sends findings to EventBridge. Then EventBridge rules can filter by severity and route this to the SNS topics. Then the SNS topic supports email subscriptions for integration with a third-party ticketing system. That could be anyone. I just gave Jira just because that was the first thing that came to my mind. So why are the other questions or why are the other answers incorrect? So let's see this one. All right, so this is EventBridge, okay? EventBridge with SES. So EventBridge doesn't support SES as a target. And then these GuardDuty ones with APIs, with filters, okay? So the create filter API doesn't support setting targets. It only creates filters for findings. Okay. All right, so we'll go for here. All right, so this is asked here. And here's where you can see, you create the SNS topic. SNS topic must be in the same region as GuardDuty. Okay, and then EventBridge, create the rule. Description, set the rule with the event pattern to match it. Then event type, GuardDuty finding, event pattern. I mean, this is walking through the whole thing. You should save this section for doing this. This is perfect. And then create the rule. If an event's triggered, then you receive an SNS topic on the SNS endpoint. That covers it. All right. 51. Next question. How do you turn on enhanced scheduling? All right, you turn on enhanced scanning for your Amazon ECR registry. By default, the duration of scans is set to lifetime. When enhanced scanning is turned on, ECR sends scanned events to EventBridge, which can be configured for further notifications to specified teams. What is the right solution fit for this requirement? So this is A. You turn on enhanced scanning for your ECR registry for the develop. Wait, what? I copied the answer to the question. Okay, so basically, what this is asking, all right, so this is saying is that basically enhanced scanning can provide both operating systems and programming language package vulnerability scanning through Inspector. All right, that's what I was trying to get through, right? So this supports continuous monitoring and a lifetime monitoring. an EventBridge integration for notifications. My apologies for this. I didn't make the questions as clear. I didn't make the questions. I had a couple of flubs. My apologies. This is going, and then just going to ask about this, but basic scanning is good for operational system vulnerabilities using the CVE database. So this is not good for programming languages. So you can see what the initial question was trying to ask about enhanced scanning for CVEs, for programming languages, and how this would be done. Okay, and GuardDuty. Okay, so GuardDuty doesn't provide ECR vulnerabilities, or ECR vulnerability scanning. Okay, you would need another tool to do that. Okay, and then Trusted Advisor. Okay, so Trusted Advisor is just a recommendation, right? It doesn't have checks for ECR registry vulnerabilities. All right, so for next question. Actually, let's go back and see what the actual question could have been, because I am curious what I was supposed to put there. So this is, yeah, it's going to be on enhanced scanning. That was, yeah. All right, so container images for operating systems and programming languages packages. Yeah, that's what it's supposed to be asking about. Which one does this? And the question was answered by this: enhanced scanning on the ECR. Again, my apologies. All right, next question. A social media company runs all its workloads on AWS and uses its organizations to implement a multi-account strategy. The company currently has multiple AWS member accounts for its departments. The company wants to enforce new security policies with the following requirements: use a centrally managed VPC that all departmental AWS accounts can access to launch workloads in subnets. The centrally managed VPC should reside in an existing AWS account, whatever account name is, right? And no departmental AWS account should use a VPC within its own accounts for workloads. And no departmental AWS account should be able to modify another department's resources within the centrally managed VPC. Which solution would facilitate the security setup to address this? So, A, use RAM, AWS Resource Access Manager, to share the subnets in the new account, centrally managed VPC with other member accounts. Then you can configure the member accounts to use the shared subnets to launch workloads. So why is this correct? So RAM enables VPC sharing, allowing centralized VPC management while maintaining resource isolation. Participants can create resources in shared subnets, but cannot modify other participants' resources, meeting all the security requirements. Okay, so why are the other answers incorrect? So transit gateway. So this is used for connectivity, not for sharing subnets or subnets for resource deployment. Okay, systems manager. All right, this cannot share VPC subnets. Okay, it's used for other purposes that are very important, but not this. And a VPC peering. So this doesn't enable sharing subnets for resource deployment in pure VPCs. All right. Okay, we'll go for the next question. A company has decided to enable Security Hub to help assess its growing AWS environment against security industry standards and best practices. Which of the following represents true statements for Security Hub? So this is saying A and B. Config must be enabled as a prerequisite when using Security Hub. Always remember that one. Then, when you enable both GuardDuty and Security Hub, the mutual integration is enabled automatically. And GuardDuty immediately begins to send findings to Security Hub. Boom. That covers a lot. Okay, so why is this correct? So Security Hub requires config as it uses config rules for security evaluations. When both GuardDuty and Security Hub are enabled, integration happens automatically with immediate finding transmission. Why are the other answers incorrect? All right. So GuardDuty. Now, see, this mixes it up. So GuardDuty is not mandatory for Security Hub. That's why C is incorrect. And okay, so operational issues with tracking. Okay, so Security Hub focuses on security issues, not operational issues like resource utilization. Okay, and then Security Hub resource linked roles. Okay, so Security Hub uses service linked roles, not resource linked roles. Okay, so let's see. Security Hub, boom, off of this. Config for Security Hub. That answers the first part of the question. Let's see. No. All right. And then how GuardDuty. Okay, so Security Hubs track its findings. Some come here. Security Hub also has a set of rules, provides tools to manage findings. All right. So this goes into how it sends it. So this works with GuardDuty. Okay. This covers the question. And you can view the GuardDuty findings in Security Hub. This is fantastic integration of these resources. All right. Let's go to the next question. All right. The company security policy mandates enforcing VPC flow logs for all the VPCs defined on AWS. A security engineer has been tasked to automate this compliance check and subsequently inform the governance teams if any VPC is found to be non-compliant. Which steps do you follow to combine for automating the process to meet the compliance guidelines? This is B. All right. Create a Lambda function that polls config to detect non-compliant resources daily and send notifications via SNS. And create a Lambda function containing the logic to determine if a resource is compliant or non-compliant. Create a custom config rule that uses this Lambda function as its source. That's perfect. Why is this correct? So custom config rules with Lambda functions can evaluate VPC flow log compliance. And then a second Lambda function can poll config for non-compliant resources and send the SNS notifications to the governance teams. So why are the rest of these incorrect? Let's go with Athena. Okay, so Athena can query flow logs. It doesn't provide information about total VPCs or which ones lack flow logs. And then, well, that would be for both of these Athenas, right? Oops. That would cover C and D, right? Athena's just not going to be this. All right, and then CloudWatch event. Okay, so Lambda doesn't propagate a non-compliant status. That's going to be critical for this. All right. All right, next question. Okay, a data analytics company processes the sensitive data of several financial institutions across the country. The company needs an automated and efficient way to identify sensitive information and operationalize security for its customers while keeping costs low. The solution should also have a security dashboard that aggregates alerts and facilitates automated remediation of security issues while having a complete view of the security architecture of the systems. A high-performing interactive query service is also needed for business purposes. What options should you combine to implement a cost-optimal and high-performance solution? So A, B, and C. Okay. Store data cost-effectively on S3 buckets and use Macy to automatically discover, classify, and protect the sensitive data. Makes sense. Configure Security Hub to have a central dashboard for higher visibility of the environment and remediate issues quickly. And then use Athena to analyze data in S3 to retrieve any amount of data from anywhere using standard SQL. So that is correct. So Macy provides automated sensitive data discovery and classification. Security Hub offers centralized security dashboarding and remediation capabilities. And then Athena provides a high-performance interactive querying of S3 data using SQL. So why are the other ones incorrect? So, okay. Okay, so detective. All right. So while this is useful, Security Hub provides more comprehensive security aggregation across multiple services, more than detective. And QuickSight. Okay, so QuickSight is good for business intelligence. This is good for those visualizations, and it's not really a security-focused interactive querying. So it's just not the optimal solution here. And then S3 intelligent tiering. This is good for cost optimization. It doesn't replace Macy's sensitive data discovery capabilities. So this answers another question, not this one. Let's see. And let's see some supporting documentation if we have it. No, didn't find it. No worries. We're having fun here. All right, next question. The project manager is connected with you for a security requirement from the client. The client wants to ensure that the authenticated encryption with associated data encryption is used when calling AWS Key Management Service encrypt, decrypt, and re-encrypt APIs. Which of the following would you recommend to address this requirement? So the answer is A. Use encryption context that you can use to verify the authenticity of KMS API calls and the integrity of the ciphertext returned by the AWS Decrypt API. So why is this correct? So the encryption context provides additional authenticated data for authenticated encryption. So it's cryptographically bound to ciphertext and must match exactly during decryption. So it ensures both authenticity and integrity without being encrypted itself. So why are the other ones incorrect? Okay, so let's start with envelope encryption. Okay, so envelope encryption fails to hit the performance optimization. So this is not good for API call authentication. All right, and then MFA. All right, so MFA is an authentication mechanism for users. It's not applicable to KMS API call validation. And then Cloud HSM. All right, so this is a hardware security module, which is not relevant to KMS API authentication. And let's get some, okay, let's get some information here. All right, so one of the most critical at KMS for advanced and secure data uses encryption context, okay? And then shows the importance. At its core, encryption context is a key value map for both strings provided KMS with encryption and decryption. That maps at encryption must match or the decryption request will fail. Encryption context provides three benefits: AAD, which we just talked about, the audit trail, and authorization. Okay, and then we can go deeply into this. But this pretty much covered it at the start. So bookmark that for your studies. All right, next question. Financial services company is evaluating storage options on S3 standard to meet regulatory guidelines. The data should be stored in a way on S3 that it cannot be deleted until the regulatory period is expired. Which of the following should you recommend for the given requirement? A, S3 object lock. Okay, so S3 object lock provides worm. So basically, write once, read many. It provides that protection, which prevents objects from being deleted or overwritten for a fixed period or indefinitely. And this is directly the way to meet your regulatory compliance requirement for your data retention processes. So why are the other answers incorrect? Let's start with Glacier. All right, so this only applies to Glacier. This is not a S3 standard. That's off the bat. Cross-region replication. Okay, so this protects against accidental deletion, but can be disabled by administrators. Okay, and then MFA delete. So MFA delete is a good security layer, but it can be disabled by the root account and doesn't directly guarantee a retention period compliance. Okay, so let's get some documentation. So S3 object lock can prevent S3 objects from being deleted or overwritten for a fixed amount of time or indefinitely. Object lock uses worm to store objects, and you can use it to help meet regulatory requirements. We got it. All right, next question. An organization manages its security and compliance units through two different AWS accounts. Both the accounts need AWS configuration and compliance data from multiple AWS accounts and regions to get a centralized view of the resource inventory. Currently, the teams use shared access to the management account to fetch the required data. To enforce enhanced security measures, the company is looking at eliminating the need to share management account credentials with the team. How will you implement this requirement with the least amount of time and effort? So the answer is A. Use the aggregator feature of config to provide access to config data to both accounts without the need to share the management account details. So why is this correct? So config aggregators collect configuration and compliance data from multiple accounts and regions into the designated accounts. And then delegated administrator accounts can aggregate organization-wide data without accessing the management account, which eliminates the credential sharing. Why are the other questions incorrect? Okay, so systems manager, let's go for that one. So systems manager, this requires management account access for multi-account aggregation. Then, no, I'm sorry, this is this systems manager. Yes. Oof, that looks bad. Okay, so this systems manager with the ops center. Okay, so this is designed for incident management, not necessarily for centralized compliance for data access. And then snapshots with config. Okay, so this is a manual approach, and it doesn't eliminate the need for management account access. All right. All right, let's get. All right, so set up an organizer using a delegated administrator account. All right, config, detailed view of resources in your org. And you can view changes and configurations between resources. Aggregator collects configuration data, compliance data from multiple accounts and in regions into a single account and region. That answers it right there. And you have the prereqs, you have the delegated administrator account, and just a member of your account. This is the answer. All right. All right. Next question. Okay. As part of the organization-wide security best practices, the company has mandated that all software installed on the EC2s should be upgraded to its most recent authorized version every 30 days. For this requirement, the security admin has to provide a weekly report that lists all the instances that do not have the latest software updates deployed. What is the most optimal way to implement this requirement? Patch Manager, yeah. So use Patch Manager, a capability of Systems Manager, to automatically scan your instances and report compliance on a schedule. Install available software updates on a schedule, and the scan will target it on demand. So why is this correct? So Patch Manager automates patching processes, right? This provides a scheduled compliance report, and it could generate reports to S3s. It also directly addresses the requirement for tracking software update compliance and reporting. All right, why are the other ones incorrect? Let's start with Version Manager. Okay, so Version Manager, this is a fictional service. It doesn't exist. All right, Change Manager. Okay, so this is designed for change management workflows, not patch compliance reporting. And then Inspector. So this is vulnerability management. This isn't designed for patch management and compliance reporting. All right. So we can get some supporting documentation. All right, Patch Manager, this answers right here, a tool that automates the process of patching managed nodes with both security-related updates and other types of updates. Boom. And you can see why it benefits: centralized patching, flexible patching, comprehensive compliance, cross-platform support, custom patch baselines. That does it. And you'll use it every day, just like I do. All right, next question. All right. An organization has added VMs, images, software, and a few databases to its AWS service catalog. These will be used by multiple development teams to build their business workloads. The organization doesn't want the end users to launch and manage products using their own IAM credentials. How will you address this requirement and implement it in the least possible time? All right. Answers A, add launch constraints to each product in the service catalog portfolio. So why is it correct? So launch constraints specify the IAM role that service catalog assumes when end users launch products, which eliminates the need for end users to have their own IAM credentials for AWS services. Launch constraints can apply at the product level. All right, so why are the other answers incorrect? So let's see, portfolio level. All right, so launch constraints don't apply at the portfolio level. They must be applied to each product individually. And let's see, service actions. Okay, so service actions, these are used for operational tasks on provision products, not for controlling launch permissions. And then we have tags. So there's no such thing as tag constraints. Only tag update constraints exist. Little trick question. All right. All right, so let's get some supporting documentation. All right, launch constraint specifies the IAM role that service catalog assumes when an end user launches, updates, or terminates a product. An IAM role is a collection of permissions that a user or a service can assume temporarily to use AWS services. That kind of goes into it. And you can go into how to configure it, how to create the launch role, and how to apply the launch constraint. This is it. All right, and that's going to be the final question. All right, so I hope this guide helped you understand the confusion areas that I personally went through, because I actually have a lot more clarity in this. I plan on taking the exam and passing, which I did originally, but I thought this would help troubleshoot the major domains within the AWS Security Specialty. So I'm done with this portion of it. I'll be going on to another selection. Until then, like, subscribe, share with anyone who's going to be taking the AWS Security Specialty. Thank you. Enjoy your day.